A very good morning to one and all present here. I am B. Sudhamathi, working as an assistant professor in the Department of Electronics and Communication in Mahendra Engineering College. Today I am going to take a topic about light emitting diode. So LED stands for light emitting diode. It is a specially doped diode which is made up of a special type of semiconductor. This LED allows a flow of current in the forward bias condition and it blocks the current while in the reverse bias. And it is an optoelectronic device which works on the principle of electroluminescence. Optoelectronic means it is dealing about the light, to study about the light. And electroluminescence is a property of a material to convert electrical energy into light energy and later it radiates a light energy. In the same way, the semiconductor in LED emits light under the influence of electric field. Next we will see about the construction of light emitting diode. So here the deposition of three semiconductor materials takes place over the substrate. It contains three layers which is arranged in one by one. The top layer which is doped by p-type material. So in p-type material the majority charge carriers are holes. Because of this charge carriers only current conduction takes place. In middle region it is an active region. The other name of an active region is a depletion region. In this region, it contains both holes as well as electrons. And finally, the bottom region is doped by the n-type material which contains a majority charge carrier as an electron. So, this is a construction of a light emitting diode. Over the substrate, n-type material is doped and above that p-type material is doped. In between n region and p region, there is an active region is there. The n-type region is said to be a cathode region and p region is said to be an anode region. Here the charge carriers like holes have a positive charge whereas electrons have a negative charge, so the light can be generated through the recombination of polarity charges. Next, this is a symbol of light emitting diode which is similar to that of the normal PN junction diode. There is an arrow mark is there which indicates the emission of light. And this is a physical component of light emitting diode which having two legs, one is short leg, another one is long leg. Short leg which is represented as cathode and long leg which represents the anode. This is next we will see about the working of an LED. So when we are giving a forward bias, biasing means giving an external supply to the device to function. So in LED, if you are giving a forward bias means the electrons and holes move towards the junction. Forward bias means that P region of the LED is connected to the positive terminal of battery and N region is connected to the negative terminal of the battery. So due to the light poles repel each other concept, the holes which is present in the p-type move towards the junction, that means a depletion region, and likewise the electrons in n-type material move towards the depletion region and the recombination takes place. So here the free electrons recombine with the holes in the depletion region. In the similar way, holes from p side recombine with the electrons in the depletion region. So due to this recombination of charge carriers, it will emit some light, that is nothing but a photons. So most of the LEDs have some voltage ratings as well as current ratings. In this rating only LED will function. Here the voltage ratings is from 1 volt to 3 volt and the forward current ratings is from 100 milliamps to 200 milliamps. If you are giving this voltage to the LED means then it functions properly due to the flow of current. But if you are applying the voltage which is higher than that of the operating voltage means then the depletion region within the LED will break down due to the high flow of current. So which causes the damage of device. To avoid this damage, here the resistor is connected in between the voltage source as well as a LED. So that's why this resistor is called as a current limiting resistor. And next we will see about the output characteristics of light emitting diode. Here the light emission is directly proportional to that of amount of forward current flowing through the LED. So this is a graph which is plotted between the forward current as well as the output light. Here if you are giving the forward current increases means the intensity of light is also getting increasing. So there are various types of light emitting diode is there. So based on the material, there is various colors of LEDs we can able to manufacture. So gallium arsenide is one of the semiconductor material which is used to manufacture infrared color LEDs. Gallium arsenide phosphide is one of the semiconductor material which is used to construct or manufacture red to infrared color, orange color LEDs. Aluminum gallium arsenide phosphide material is used to construct high brightness red, orange and yellow color LEDs. Gallium phosphide which is used to construct red color, yellow color and green color LEDs. Aluminium gallium phosphide is used to construct green color LEDs, and gallium nitride material is used to construct green, emerald and green color LEDs. Gallium indium nitride which is used to construct near ultraviolet, bluish green and blue color LEDs. There are various advantages there in LED. LED which consumes low energy when compared to the normal PN junction diode, and light emitting diodes is very cheap and it is readily available, light in weight which is smaller in size, and it have high reliability which means it have longer lifetime. Its switching speed is very fast when compared to the other devices. It can emit different colors of light. Even though it has many advantages, one disadvantage is there, that is luminous efficiency of light emitting diode is very low, which means luminous efficiency is nothing but how the light source which generates a visible light. The unit of luminous efficiency is lumens per watt, and for LED the luminous efficiency is 300 lumens per watt. And there are various applications of light emitting diode, which is nowadays we are using indicators, and in a display panel indicator, that is in a traffic signals, and also the display boards they are using an LED, and in digital watches, calculators, multimeters, remote control systems and burglar alarm systems. So next we will see the overview of a light emitting diode. So light emitting diode works on the principle of electroluminescence. Electroluminescence means the electrical energy is converted into light energy. So it allows a flow of current in the forward biased condition only, and it blocks the current in the reverse biased condition. So they are constructed by the deposition of three layers, which means a P layer, active region as well as N layer. When we apply the forward bias, the charge carriers like holes and electrons move towards a junction, and the recombination of polarity takes place, so the light can be generated. The amount of light emission is directly proportional to the amount of forward current. So these are all the possible questions which we'll ask in this topic. That is a list of applications of LEDs. Then you can able to explain the basic working principle of LED and why LED is operated in forward bias. What is the biasing current and voltage rating of LED? And they will detailedly explain about detailedly asking about the construction and working of LED. Thank you.